All right, so you're a developer. We've all been there, right? You've got a bunch of different code snippets, they all work on their own, but then you hit that wall. How do you actually stitch all these pieces together into a real, professional app that doesn't fall apart? It's a huge jump, and honestly, it can feel a little daunting.
So how do you make that leap? How do you structure a full-stack project so that it's not just a house of cards? You want something that's solid, that can scale, and that you can come back to in a year without wanting to tear your hair out.
Well, it turns out the secret isn't some crazy complex formula. It really just boils down to getting two foundational decisions right from the very beginning. Think of them as the two pillars that hold up your entire application. You get these right, and everything else just kind of falls into place.
Okay, let's talk about the first and, you could argue, the most important pillar: how you model your data. This isn't just some boring database theory. With a database like MongoDB, how you structure your data is a decision that will either become your best friend or your worst enemy down the line. Its effects just compound over time.
In a document database, you've basically got two main moves. First, there's embedding. That's where you nest related data, like comments, right inside the main document, like a blog post. Or there's referencing. That's where you just store a little pointer, an ID, to a document that lives in a completely different collection, like a user who wrote the post.
So, when do you embed? The rule of thumb is pretty clear. You do it when the data is super tightly connected. Think about it. A comment on a post doesn't really mean anything without the post itself, right? This approach is awesome for performance because you grab everything in one go, and it's great for keeping your data consistent.
And on the flip side, when do you reference? Well, you do this for data that has its own life. A user is a perfect example. They exist on their own, outside of any single post they write. They might write 100 posts. So in that case, referencing is the clear winner. It keeps things clean and way more flexible.
But, and this is a big but, embedding has a secret enemy, a hard, non-negotiable limit. Every single document in MongoDB has a size cap, and that number is 16 megabytes. That's your absolute ceiling.
And this leads us straight into what I call the 16 megabyte trap. Imagine you embed comments in a blog post, and that post goes viral. You're getting thousands, maybe tens of thousands of comments. Awesome, right? Well, not for your database. That array of comments is just growing and growing, getting closer and closer to that 16 megabyte limit. If you hit it, your app just stops. No more writes to that document. It's a silent time bomb in your code.
Okay, let's shift gears to pillar number 2. Once your data is all nicely structured, how do you actually get it from the database onto the user's screen? The great news is that with modern frameworks like Next.js, the mental model for this is actually beautifully simple.
It breaks down into 3 very distinct paths. Number 1, for just reading data in your app, you talk straight to the database from your server components. No API needed. Number 2, for writing data, creating, updating, deleting things, you use server actions. And number 3, for anyone outside your app, like a mobile client or a webhook, that's when you build a classic API with a route handler. A specific tool for every job. And here is the most crucial takeaway from that pillar. Stop building APIs to talk to yourself. A really common beginner mistake is to build an API route and then fetch from it inside your own server component. That's a totally needless trip over the network. Your code is already on the server. Just go get the data. It's simpler and it's way, way faster.
So, we have these 2 big ideas, or 2 pillars. But what does that actually look like in a real project, in your code editor? This is where the theory hits the pavement and starts to give you a project structure that's actually a joy to work in.
The core principle is so simple but so powerful. Organize your code by what it does, by its concern, not just by what type of file it is. All your server actions, they live together. All your database queries, they live together. Trust me, when your project grows to hundreds of files, your future self is going to thank you for this.
And now for the best part, the real payoff. When you get this foundation right, you suddenly unlock some seriously clean, powerful, and elegant coding patterns. It's like the reward for doing your homework up front. Let's look at 3 quick examples. First up, runtime validation with a library like Zod. This is like having a bouncer for your database. It checks the data not just when you're writing the code, but when your app is live and getting real user input. You define your data shape once, and you get protected at compile time and at runtime. It means you can be completely confident that no garbage data ever gets into your database. Second, something that used to be a massive pain, keeping your UI fresh.
Look at this single line of code. You stick this inside a server action after you create a new post, and bam, Next.js instantly knows it needs to refresh the data for your entire blog page. The UI is always in sync automatically. It's practically magic.
And third, atomic updates. The old way to delete an embedded comment might be to fetch the whole post, manually filter the comments array in your code, and then save the whole thing back. Instead, with an operator like @pull, you just tell the database, hey, pull this one item out of this array. Done. It's one single safe operation. It's faster and avoids all sorts of nasty bugs.
So if you take just one thing away from this explainer, let it be this. Building a professional, scalable app isn't about mastering dozens of hyper-complex patterns. It's about being absolutely crystal clear on a few foundational pillars, like how you model your data and how you move that data around.
And that kind of leaves us with a bigger, more interesting question, doesn't it? As these frameworks bring the front and back ends closer and closer together, maybe the defining skill of a great full-stack developer isn't just about building APIs anymore. Maybe it's about being a true architect of the entire system. What do you think about that?